The real reason submarine cables are so expensive? Hello everyone, and welcome back to my channel. Today we're diving deep literally into a fascinating piece of technology that powers our modern world. Underwater power cables. These massive engineering marvels have been quietly running beneath our oceans for decades, carrying electricity and data to islands, offshore platforms, remote regions, and even entire countries. But as the world shifts toward renewable energy, especially offshore wind farms and tidal power, these cables aren't just bringing power to the sea, they're also carrying clean energy from the sea back to our homes. So how do they work? How are they built? And why are they so expensive? Let's find out. The role of submarine cables, underwater cables, are absolutely essential for modern life. They provide electricity to places where there are no power plants on site, such as islands or oil rigs. They serve as the backbone of global telecommunications, allowing continents to stay connected. And more recently, they're replaying a vital role in transporting renewable energy from offshore wind farms and solar farms back to the mainland. Without these cables, vast areas of the world would be left in the dark literally and digitally. Built to survive the ocean now, as you might expect, these cables aren't your average household wires. The ocean is a brutal place. Saltwater corrosion, shifting seabeds, storms, anchors, and even marine life all pose constant threats. That's why every part of an underwater cable is designed to endure extreme conditions. Inside, you'll find a carefully engineered cross-section that looks like a piece of futuristic art. It's high-quality copper or aluminum conductors at the core, layers of insulation to prevent energy loss, protective sheaths made of steel, lead, or aluminum, petroleum jelly or other fillers to block water intrusion, and finally, thick armor-often steel wires wrapped around the cable to withstand crushing pressure and physical impact. The result is a cable that can last up to 25 years under the sea, all while carrying massive amounts of energy. The price of power, but all this advanced technology comes with a serious price tag. Some high-capacity submarine cables can cost as much as $400 per foot. That may not sound like much at first, till you realize that hundreds of thousands of miles of these cables already crisscross the ocean floor. We're talking billions of dollars in investment from governments and private companies. And yet the efficiency gains are enormous. Once you needed 2 or 3 separate cables, modern designs can now carry the same power in just one, making installation and maintenance much more cost-effective. Manufacturing the giants. The manufacturing process of these cables varies depending on their purpose. High-voltage cables that span long distances are built differently than shorter medium-voltage ones. Factories typically produce them in giant lengths and wind them directly onto enormous spools or drums. These are then transferred to specialized ships for installation. Each layer, whether it's insulation, steel armor, or protective tapies, carefully added to ensure maximum durability. By the time the cable is finished, it may be several inches thick and weigh dozens of tons, ready to face decades beneath the waves. How cables are installed. So how do you actually lay one of these massive cables across the ocean floor? That's where the real magic happens. Specialized cable-laying vessels take on the job. These ships are equipped with massive rotating storage drums for the cables, mooring systems to keep them steady in rough seas, flat bottoms that reduce motion while working in both shallow and deep waters. Before installation, the crew sends down remotely operated underwater vehicles, also known as ROVEST, to scan the seabed. They make sure there are no obstacles that could damage the cable. Once the path is clear, the cable is slowly unspooled from the ship and guided to the ocean floor, with rafts constantly monitoring its placement. In shallow areas or busy shipping routes, trenching robots may bury the cable under the seabed for extra protection. At each endpoint, whether it's a power station on land or an offshore wind farm, the cable is carefully cut, connected, and sealed. It is a process that takes immense precision and can last weeks or even months depending on the project. Recycling old cables, but what happens when a cable reaches the end of its lifespan? Interestingly, they're not just abandoned on the seabed. Many are retrieved and recycled. At specialized plants, decommissioned cables are cut into manageable pieces, stripped open, and separated. Valuable metals like copper and aluminum are salvaged, along with steel armor and other materials. These components are worth millions of dollars and can be reused in new cables, electronics, or other industries. So even after retirement, submarine cables continue to provide value. A look back in history, what's truly fascinating is that this technology isn't new at all. In fact, submarine cables date back more than 150 years. The very first transatlantic telegraph cable was laid between 1854 and 1858, connecting Ireland to Newfoundland. It could send messages across the ocean in just minutes, something revolutionary for the 19th century. Of course, those early cables were laid by slow steamships with minimal precision. Today, we have advanced ships, GPS-guided placement, and robotic systems that ensure cables are laid with incredible accuracy. Challenges beneath the waves now. Despite all the advancements, submarine cables are not invincible. They face a surprising number of threats: anchors and fishing nets. One wrong move from a passing vessel can snap a cable and cut power to an entire island. Marine life. Believe it or not, sharks and other creatures have been known to bite cables, damaging insulation. Natural hazards. Earthquakes, shifting seabeds, and undersea landslides can all damage cables. Repairing a damaged cable is a slow, costly process. The broken section has to be located, dredged up from the ocean floor, repaired or replaced, and then carefully lowered back into place. It's a massive engineering challenge every time it happens. The future of submarine cables. As the demand for renewable energy and global connectivity continues to rise, we'll be seeing even more of these underwater cables laid in the coming years. Offshore wind farms, undersea data transmission, and cross-country power sharing will all depend on them. That means cable-laying ships will become an increasingly common sight in ports and oceans around the world. And with new materials and designs, future cables may become even stronger, cheaper, and more resistant to threats both natural and human-made. Conclusion. So, the next time you flip a light switch or send a message across the globe, remember this. Somewhere deep beneath the ocean, a thick, heavily armored cable is quietly making it all possible. From carrying renewable energy to connecting continents, submarine cables are one of the most important, and least visible technologies of our modern age. That's all for today's video. If you found this exploration of underwater power cables interesting, don't forget to give it a thumbs up, share it with your friends, and subscribe to the Fluish channel for more deep dives into technology and engineering. Thanks for watching, and I'll see you next time.